to check out what the meaning of the our class of today, the probability distribution events, and you just only in the exams and these things you will get it ready made, and only you will do your calculus. But I just want to show you how it looks the decision tree. The squares always is a point of decision, a decision. So we represent the squares for the decisions. The circles is for the events of the probability distributions, of the events of the probability distribution. Let me show you this with an example now. On the board, just to be very clear in your minds, to be very clear in your heads, we set the probability distribution like this. Here is a point of decision. Here in the squares are point of decision. DECISION. It's a decision. While when it's for that reason they say decision tree, because it looks like the tree. It's branches, like the tree branches. Here, those points are for the events. From those points of the events come to us the branches. And those branches are with a probability distribution. Usually on the branches, it should complete 100%. As example, if this is 20% and this is 30%, then 20 and 30, 50, then the third branch will be 50%. Again, for the second one and the third one, the same thing. If it is here 60% on this branch and here 20%, then I expect that this branch also will be 20%, because all of them have to be 100%. So you put as example cases and is probabilities for something will happen in the future time, something that will happen in the future time, and you put for it just probabilities. Like as example, if it rain or mild, or it's okay mild, if it is bad situation, if it is good situation, then you will put for yourself, I will sell with $100 with 20% sure, 20% sure that I will sell with $100, or 30% sure I will sell with $200, or 50% sure that I will sell with $700. So this is how the probability distribution works. What we do actually, we will multiply each one in the probability and get the expected value. We will get something called expected value, and then we will see which one of them is greater, then we will make the decision. So first we will draw the tree, and in the exam I believe that I will give you a tree drawn already, just drawn already. You won't draw it, you won't draw graphics, you'll find the graphics. And what you will do only, but just to understand that this point is a decision because it's square, so it's a decision point. And those circles is events means that I will give it expected value. What's the meaning of expected value? Means it's based on probability distribution. What do we mean by probability distribution? You have more than one state of nature, and you have to put probability distribution for them. But all of them will come to 100%, 20%, 30%, 50%. That all comes to 100%. Same thing for here. Same thing for the third branch. Let's go now for an example of the decision tree. Instead of talking too much, let's go for our example of the decision tree. Here it is, the same thing which is in the board, but here I made it from right to left. Here it's made from left to right, that's fine. So I have LS Seafood Company, and they have the decision. Let me give you an example first about this, just give you a bit feedback. Here are the calculations, methods of evaluation. We will get the expected value. The expected value will equal the summation of P, the probability, and the financial, the cost, the financial results, whatever it's cost, revenues, or whatever. So we will do multiplication. It's very easy. It's very easy. When it's just by the formulas, it looks difficult, but when you come inside it, you will find it very easy right away. So here it is, before drawing it. But as example, I told you, I will give you a drawed one already. Already you will have the graph. You will just make the calculus of it. So don't bother yourself about this. But at least you will know that the low demand, we have three cases of nature: low demand, medium demand, high demand. And in the low demand, we have 30 shipments per year, here 50 shipments per year, 80 shipments per year. What we care about is the percentage: 25%, 80, 60%, 15%. That's what we care about. Okay. And this is how it will be calculated at last. But before I come to the calculations, how we did it, let's go to the how will we do the graph. Like I told you, draw the tree form. Here is the tree form behind me. Here it is. And it is in the example, the tree form. This is how it looks, like a tree. Draw the tree form. Represent decisions points with squares, like I told you. Like I told you. The present here, the squares is for the decision. What do we mean by decision? We have three alternates. We have to choose one of them. The word decision means that I have three alternates here, but I have to choose only one of those alternates. And elsewhere, we'll go back to the third, represent outcomes points of the circles. That's what means, like I will show you now. On these points, you will get as let me tell you something. 14 by 25%, 20 times 60%, 29 times 15%. You will calculate all of them together. They will give you 19,850. The second, this is very simply how you will solve it. It's just multiplication, then addition. 14 times 25% plus 20,000 times 60% plus 29,000 times 15%. That's all. When you calculate it, it will come to 19,850. And this is the first one. Second one, 22,500, you will multiply by 25% plus 37,500, you will multiply by 60% plus 60,000 multiplied by 1,500. And when you add all of them together, they will be 37,125. Third one, 22,500% 500 multiplied by 25% plus 23,500 multiplied by 60% plus 25,000 multiplied by 15%. I just want you to notice that every branch of the tree, the whole probability distribution must be equals 100%. 100%, because you know that the sum of the summation of the probabilities equals 1 or equals 100%. As example, 25% and 60%, that's 85%. Plus 15%, that's all comes to 100%. Let's look at this. 25% plus 60% plus 15%, that's all when you calculate it 100%. If I give you one missed of them, then you will say 100% minus the other two. Then it will give you the missing one. Okay, if this 15% was not there, and I put for you a question tag, question marks, then you will say 100% minus 25 plus 60%, then it will give you 15%. Same thing. Why did we say this is a decision point? Because we will have three alternates. If it is revenues, you will take, I'm saying again, if it was a condition, the case is a revenue, then you will choose the highest number. If the case was costs, then you will choose the lowest costs. That's the difference between the two cases. So here we have demand outcomes. This is will be results, or this is, so we will put it in the choose the highest one of them, or the lowest expected value. Lowest expected value, like this way. Let's see here how we'll formulate it. Okay, this is the law, the rules and the formulas. Ellison Seafoods wants to know the expected cost. As long as we talk about cost, then we will take the lowest value. But if this was revenue, then we will take the highest value in the decisions. Okay, One of the option contracting the management has identified some potential demand scenarios and assigned probabilities for them. And here it is. And when we draw it, it became like that way. Because here at the decision point, here, as long as circles, that means we will have probability distribution. So when there is probability distribution, states of nature, probabilities, we will draw circles. When there is a kind of one decision, means you will take only one alternate of those three, one of them, then we will take put it in a square. And the decision is made based on what is this tree about? Is it about costs or about revenues? If it is about revenues or earns or wins or profits, in all this you will choose the highest of them. If it was like such this case about the costs, then you will choose the lowest of them. If it is cost, you will choose the lowest. If it was revenues, you will choose the highest. Okay, it's very easy now. What we will do is this the calculus here. The EV contracts and the common and lease. What the contract and the common and lease? Look at this. A branch for the contract, a branch for the common, a branch for the lease. Okay, that's first. Let us see the contract. The contract, 14,000 by 25%, time 25%. Let's go to it. Here, 14,000, 14,000, 25%, plus 20,000 plus times 60%, plus 29,000 times 15%. Let's go for the solution here. 14,000, 25%, 20,000 times 60%, 29,000 times 15%. That comes to 19,080 $850. So where I will put this here after I finish. 14 by 25, 20 by 60, 29,000 by 15%, and all of them together when I make a submission for them, they will come 19,850. Same thing which I did for the contract, I will do for the common. The common here is, let's see the common. The common, here it is, 22,500 by 25%. Look at this, 2200, 500, 22,500 by 25%, plus 37,500, 60% times 60%, plus 60,000 times 15%. The same thing here. Then the third is lease. If I will lease, how much the cost will be if I lease? 22,500 times 25% plus 23,500, 60% plus 25,000 times 15%. Here we go, the lease. Here it is, 20 times 25, 23,500 times 60, 25,000 times 15%. That will give me 23,475. So what is my decision here? Those are costs. Of course, I will take the lowest costs. The lowest costs here is this number. Actually, this one, 19,850, because 37 is more and 23 is more. As long as I'm dealing with costs. How did I know that I will choose the lowest? Because he told me in the example the expected costs. But if he told me revenues, then the issue will be different. In that case, I will choose the highest number, not the lowest number, but I will choose the highest number. As long as he told me that it's not a matter of cost, but it's a matter of revenues. So I will choose the highest revenue. This is how, and this is the end of the decision trees. Just again, you'll draw the tree. You won't draw it because I will give it to you ready made, but just to know what do we mean by the tree. Then the decision points is in squares, and the events points, the outcomes points in circles, which including the probability distribution. Wherever there is probability distribution, put it in circles. Then the expected value. How you will get the expected value? You will multiply the numbers, these numbers, by the probability distribution. Always make sure that each branch is 100%. Each branch this is a branch, this is a branch of the tree, this is a branch of the tree. Each branch of them make 100%. Not more, not less, because the probability, all the probabilities of an event equals 100%. So they must complete it. And I told you, if you miss something, if one is missed, then you will get it by subtraction from the 100%. And here we go. And this is our example for today. Uh, I wish you a good night. Thank you.